Our last grouping of ideas for this section are associated with Newton's law of cooling. So let's start off with an example so you have an idea of what this is all about. What I like to think about when I think about Newton's law of cooling is a big turkey that I just brought out of the oven and I put on a big Thanksgiving table. Now, that turkey is going to start off at some initial temperature, and then as time goes on, the temperature is going to be going down. However, on problems that we were looking at earlier, the general idea of exponential decay, we would have something that was eventually going to zero. In this case, when you think about my turkey, it won't necessarily go to a temperature of zero. Frequently what's going to happen is that my turkey is going to go to the temperature of the surrounding medium, which is meaning the air temperature of my room. So eventually my turkey is going to be the same temperature as the rest of the room, and frequently that isn't going to be zero. So what we're going to find is that when we graph these kinds of problems, instead of having a horizontal asymptote that's associated with the t-axis down here, we're going to have a horizontal asymptote that's a little bit higher. It's going to be the surrounding temperature of the medium that the item is in. So again, for my turkey, it's going to be my room temperature. So, okay, let's start off with the original temperature of my turkey, and then it's going to go downhill. But one more time, it's only going to go downhill until it hits that horizontal asymptote. It's not going to go past that horizontal asymptote. It's not going to go all the way down to the t-axis. So it gets lower and lower and lower. So the question then is, how does that affect our function? Well, it's still going to be an exponential function, but we have to put a couple of pieces in here to demonstrate the idea that we're going down to this horizontal asymptote of u equals t. Now, you might be looking at Newton's law of cooling and wondering, why didn't they choose T for temperature? They chose U to describe the temperature of our turkey. Well, the reason is we had a lot of T's already around. So we have lowercase t that represents the time on this problem, and we have capital T that talks about the temperature of the surrounding medium. So we can't use lowercase t and we can't use capital T, so they had to use a different letter, and they chose U to represent the temperature of our item. So U of t is going to be the temperature of our item at any given time, and it's going to be capital T plus the quantity u sub 0 minus t times e to the kt. So these first two pieces are a little bit different, but this last piece, e to the kt, once again feels familiar from what we were looking at earlier.